Hi friends, welcome to the dj.anshi YouTube channel. Today we are going to discussing the concepts of the singular points. Singular points concept tilkoku munche, let me discussing some small concepts: concavity, convexity and the point of inflections. The first one, concave upward or convex downwards. The curve is said to be concave upward at point A if the portion of the curve on the both side of A lies above the tangent to the curve at A ಅಂತ ಹೇಳ್ತೀವಿ. Observe this curve. This is a curve. It is a point. In that point, what we say, the curve is said to be concave upward at point A. In this point, we say the concave upward if the portion of the curve on both sides of A. This is the portion of the curve on both sides of A. This is one side and this one side. Both sides of the A lies above the tangent to the curve at A. This is a tangent. The curve is lies above this tangent. Then we say the curve is concavely upward. The condition is d square y by dx square is greater than 0. It is the conditions for concave upward or convex downward. Okay. The next, convex upward or concave downward. The definition is the curve is said to be convex upward at point A if the portion of the curve both sides of A lies below the tangent to the curve at A. Observe this graph. In this case, this is the tangent, this is the point A. This is the point A. In that point, the portion of the curve both sides of A lies below the tangent. This curve is lies below the tangents at A. Then we say this curve is convex downwards. Okay, the condition is d square y by dx square is less than 0. If the concave upward, the condition is d square y by dx square is greater than 0. If the curve is convex upward, the condition is d square y by dx square is less than 0. The next point is point of inflections. The point of inflection means if at a point P a curve changes its concavity upwards or downwards or vice versa, then P is called point of inflections. You observe this graph. In this case, at point P the curve is concave upward. In this case, the curve is concave downward. Hence, we say this point is point of inflection. Got it? Let me move on to the problem. Prove that y is equal to e power x is everywhere concave upward. Write down this. Y is equal to e power x. You differentiate this, you get dy by dx is equal to e power x. E power x differentiation is e power x. Again differentiate d square y by dx square which is equal to the e power x. We concluded that d square y by dx square is greater than 0. Why you write d square y by dx square is greater than 0? Because you applying x is equal to 0, you get e power 0 is equal to 1, which is greater than 0, and you applying e power minus of, which is also a greater than 0. The exponential of minus 1 by 2, which is 0.60, which is greater than 0. Since we say d square y by dx square is greater than 0. Since this curve is concave upward everywhere. The next problem is find the range of values of x for which the curve y is equal to x power 4 minus 6x cube plus 12x square plus 5x plus 7 is concave upwards or concave downwards. Write down the given equation of the curve. Y is equal to x power 4 minus 6x cube plus 12x square plus 5x plus 7. You call this as equation number 1. You differentiate with respect to x. You get dy by dx which is equal to x power 4 differentiation is 4x cube minus 6x cube differentiation is 18x square plus 12x square differentiation is 24x plus 5x differentiation is 5. Next, you differentiate One more time, you get d square y by dx square, which is equal to 12x square minus 36x plus 24. For concave upwards, we know the conditions d square y by dx square, which is greater than 0. First, we consider d square y by dx square, which is equal to 0. d square y by dx square is 12x square minus 36x plus 24, which is equal to 0. Divide throughout by 12. We get x square minus 3x plus 2, which is equal to 0. You simplify this through the factorizations, you get the values of x, which is equal to 1 comma 2. Observe the real line. This is minus infinity to plus infinity. The points are 1 comma 2. In the intervals minus infinity comma 1. In minus infinity comma 1, the d square y by dx square, which is greater than 0. For understanding, I put the values in between minus infinity comma 1. I take the 0, which is lie in between minus infinity comma 1. Put x is equal to 0 to d square y by dx square. We get the value is 24. The 24 is greater than 0. So we said the d square y by dx square is greater than 0. So the curve is concave upward. So we say the curve is concave upwards. In the intervals 2 comma infinity, in 2 comma infinity, the d square y by dx square is also greater than 0. I will take the x values as 3. The 3 value lies in between these interval. Put x is equal to 3 to this equations. I get the value is 24. The 24 value, which is also greater than 0. So we say the d square y by dx square is greater than 0. So the curve is concave upward. Next, in between the intervals 1 comma 2, like I take 1.5. I take 1.5. Put x is equal to 1.5 to this equations. I get the value is minus 3. The minus 3 is less than 0. Minus 3 is less than 0. So we say the d square y by dx square, which is less than 0. So the curve is concave downwards. The curve is concave downwards. For the point of inflection, d square y by dx square, which is equal to 0. The d square y by dx square is 12x square minus 36x plus 24, which is equal to 0. I get the values is 1 and 2. Put x is equal to 1 in equation number 1. Equation 1 is y is equal to x power 4 minus 6x cube plus 12x square plus 5x plus 7. Put the values is x is equal to 1. I get the value of y, which is equal to 19. So therefore the point of inflection at x comma y, which is equal to 1 comma 19. Put x is equal to 2 in the equation number 1. I get the value of y is 33. Therefore the point of inflection at x comma y, which is equal to 2 comma 33. Therefore the point of inflections are 1 comma 19 and 2 comma 33. I hope that you are understood the concept of concave upward, concave downwards, and the point of the inflections. Let me move on to the singular points. What it means singular points? The point p of x comma y of the curve f of x comma y, which is equal to 0, at which point both the partial derivatives dou f by dou x and dou f by dou y vanish, is called singular points of the curve. Okay, this is the definitions. It is very important questions. It may ask in the 1 mark problems. Okay, the note number 1: every curve need not have a singular points. Every curve need not have a singular points. Let us consider the curve ellipse x square by a square plus y square by b square, which is equal to 1. Let f of x comma y, which is equal to x square by a square plus y square by b square, which is equal to 1. We differentiate partially with respect to x. We get dou f by dou x, which is equal to 1 by a square is constant. It is as it is. X square differentiation is 2x. This derivative is 0. Okay, and We differentiate partially with respect to y. We get dou f by dou y which is equal to 2y by b square. This derivation is 0 and this one is also 0 because we differentiate partially with respect to y. Next, we put dou f by dou x which is equal to 0. We get x is equal to 0. And we put dou f by dou y which is equal to 0. Dou f by dou y is 2y by b square is equal to 0. We get y is also a 0. Thus we say the dou f by dou x and dou f by dou y both vanish at 0 comma 0. At 0 comma 0. But 0 comma 0 is not a point on the curve. 0 comma 0 is not a point on the curve. Hence ellipse has no singular points. Ellipse has no singular points. Okay. The note number 2. If a point P of x comma y is an ordinary point on the curve f of x comma y is equal to 0, then there exists only one branch of the curve through the points. If the point is an ordinary point. Okay. If a point P of x comma y is a singular point, if a point is the singular point on the curve f of x comma y is equal to 0, then there may be more than one branch of the curve through the points. We say more than one branch of the curve through the points. P of x comma y ಅನ್ನೋದು singular points ಆಗಿದ್ರೆ ಆ points ಮೂಲಕ more than one branch of the curve ಏನಾಗುತ್ತೆ ಪಾಸ್ ಆಗುತ್ತೆ. If there is P of x comma y is an ordinary points agidre on the curve f of x comma y is equal to 0, then there exists only one branch of the curve. A points alli a points mulaka only one branch of the curve enagutte pass agutte anta. Okay, let me move on to the problems. Find the singular points on the curve x cube plus x square plus y square minus x minus 4y plus 3 which is equal to 0. I denote this as f of x comma y which is equal to x cube plus x square plus y square minus x minus 4y plus 3. We differentiate partially with respect to x. I get dou f by dou x which is equal to x cube differentiation is 3x square plus x square differentiation is 2x. Next this one will be 0 minus 1 minus x differentiation is minus 1 minus 4y differentiation is 0 3 differentiation is 0. Next, we differentiate partially with respect to y. We get dou f by dou y which is equal to 2y minus 4. Put dou f by dou x which is equal to 0. Dou f by dou x is 3x square plus 2x minus 1 is equal to 0. If you simplify this, you get the roots as x is equal to minus 1 comma 1 by 3. And put dou f by dou y which is equal to 0. Dou f by dou y is 2y minus 4 which is equal to 0. You get the value of y which is equal to 2. Therefore, the possible singular points are minus 1 comma 2 and 1 by 3 comma 2. 1 by 3 comma 2. F of x comma y which is equal to x cube plus x square plus y square minus x minus 4y plus 3. At this point, at minus 1 comma 2, f of x comma y puts x value as minus 1 and y value as 2 to this equation. You get f of x comma y which is equal to 0. You get f of x comma y is equal to 0. It is f of minus 1 comma 2. Hence we say it is a singular point. At 1 by 3 comma 2, f of x comma y which is equal to, put x value as 1 by 3 and y value as 2 to the equation of the curve. We get the f of x comma y value is minus 32 by 27 which is not equal to 0. Hence we say it is not a singular point. Therefore the singular point is minus 1 comma 2. Got it, sir? I hope that ಇವಾಗ ನಿಮಗೆ singular points ಅಂದ್ರೆ ಏನು ಅಂತ ಅರ್ಥ ಆಗಿರುತ್ತೆ. So we say the singular points is the point P of x comma y of the curve f of x comma y which is equal to 0 at which point both the partial derivatives dou f by dou x and dou f by dou y vanish is called singular point of the curve. What is the another definitions of the singular points? The singular points can be defined as a point on the curve at which the curve behaves in an extraordinary manner is called singular points. In that point, the curve behaves as an extraordinary manner. Hence, that point is called it as the singular points. In singular points, we see two types of points. One is the point of the inflections and second one is the multiple points. You know about the point of inflections in the previous section. Let me move on to the multiple points. What it mean multiple points? The multiple points means a point through which more than one branches of curve is passed. It is called as the multiple points. Look here the graphs. This is the points. In these points, only one branch of the curve is passed. Hence, we say that as single point. Look here. This is x-axis and this one is y-axis. It is one branch of the curve. It is one branch of the curve. It is another branch of the curve. In this case, in this point, two branch of the curve is passed. So we say it is the double points. This point is called it as double points. And triple points. Triple points means in this point the three branches of the curve is passes agirate. Look here, this is one branch of the curve and this one is another branch of the curve. This one is the third branch of the curve. So we say the triple points. This point is called it as triple points. Okay. Look here in this graph. This point is called as quadruple points. Because in this graph, four branch of the curve is passes. This one branch of the curve and this one branch of the curve and this is also one branch of the curve. This is another branch of the curve. In this point, four branches of the curve is passed. Hence, we say this point as quadruple points. Got it, sir? So, what it mean the multiple points? Multiple points means a point through which more than one branches of the curve is passed is called as the multiple points. The multiple points is called as the double points. It is also called as the double points. The double points means a point through which two branches of curve is passed is called as double points. Look here in this graph, two branches of the curve is passed. Okay, so this point is called it as the double points. Okay, next one is the types of the double points. In this double points, we see three types of the double points. One is the node and second one is the cusp. Second one is the cusp. Third one is conjugate or isolated points. Conjugates are isolated points. What it mean node? A double point is called as node if distinct branches have distinct tangents. If distinct branches have distinct tangents. Look here, in this case, this is a curve. This one is the curve and this one is the curve. Through which points the two branches of the curve is passed. Hence, this point is called as the double points. The double points. This double point is called as the node if distinct branches. Look here, this one is the one branch and this one is another branches. The two branches have two tangents. Look here, this one will be the tangents T2 and this one is the tangents T1. Distinct branches have distinct tangents. We say this point is node. Got it? What is node? Node means a double point is called as node if distinct branches have distinct tangents. Okay. The next one is cusp. What it mean cusp? A double point is called cusp if two branches have common tangents. Look here. This is a point. This is a point. This is one branch of the curve and this one is the another branch of the curve. Through this point, two branches of the curve is passed. So we say this point as double points. So this double point is called as cusp if two branches have common tangents. Look here, this one is the one branch and this one is another branch. The two branches of the curve have the same tangents. Look here, this one is the tangents. The two branches have same tangents, so we call this point as the cusp. Similarly, look here in this graph also, this is the two branches of the curve. Two branches of the curve has same tangents. Same tangents, so we call this point as the cusp. Okay. Next, we see the types of cusp. We see two types of the cusp. One is the single cusp and another one is the double cusp. Single cusp means the curve lie on same sides of the common normal. Look here, this is two branches of the curve. Two branches of the curve. This is the double points. It has the common tangents. It has common tangents. Hence, this point is called as the cusp. This point is called as cusp, and also they have the same normal, same sides of the normal, so we say it as a single cusp. In the single cusp, we see the two types: single cusp of first series and single cusp of second series. Single cusp of first series means the curve lie on same sides of common tangents. You look here, the curve, the two curves, the curves, two curves have same tangents and only common tangents and only, so we say this as single cusp of first series. Okay, single cusp of second series. Single cusp of second series means the curve lie on opposite sides of common tangents. Look here, the curves as opposite sides of common tangent. This is the tangents. The curve lie on opposite sides and has same common normals. So we say it has single cusp of second series. Okay. Next one is the double cusp. Double cusp means curve lie on both sides of common normal. Look here, this one is the curve, this one is another curve. The two curves as both sides of common normal. In the single cusp, only one side of the common normal can be seen. In the double cusp, we see both sides of the common normal. So we say it has the double cusp. Next, in the double cusp, we see two types of double cusp. That is double cusp of first series and double cusp of second series. Double cusp of first series means the curve lie on same sides of common tangents. Look here, this one is the tangents. They are the two curves. This one is the one curve and this one is the another curve. Okay, this is the common normal. We see the curve lie on both sides of the common normal. We say this as the double cusp, and the two curves have same common tangents, same sides of common tangents. Hence we say the double. It has double cusp of first series. Next, double cusp of second series. It means the curve lie on opposite sides of the common tangents. Opposite sides of common tangents. Look here. This is the tangents. They are the curves. It is the normal. The normal ಏನಾಗಿದೆ ಎಲ್ಲೋ ಕಡೆನೂ ಕೂಡ ಲೈ ಆಗಿರುತ್ತೆ. We see the curve lie on both sides of the common normals, and the curve lies on opposite sides of the tangents. So we say it has double cusp of second series. The next point is isolated points or conjugate points. What it mean isolate points and conjugate points? A point is called conjugate point if it such that there exists no other real points in the curve in its neighborhood and two tangents at a double points are imaginary. Two tangents at a double points are imaginary, then the point is called as the conjugate points or isolated points. Look here in this graph, this is the curve and this is the points. Okay, we call this point as the conjugate points if it such that there exists no other real points on the curve in its neighborhood. Okay, that's about the multiple points or double points. In the next sections, I will move on to the working rule of the double points and nature of the double points. If you have any doubts regarding this concept, please ask me in the comment section. If you like a video, please like, comment, share and also subscribe. Thank you for watching.